Hello everyone. Let's start with something simple. Every day, we push, pull, lift, or feel resistance, from the weight of your school bag to the attraction of a magnet, from lightning in the sky to the gravity that keeps you on Earth. But did you know? All these countless forces in nature actually come down to just four fundamental forces. These are gravitational force, weak nuclear force, electromagnetic force, and strong nuclear force. Together, they govern everything from the tiniest particle interactions inside atoms to the motion of galaxies across the universe. Today, let's explore each of these forces, their properties, and their importance in shaping the natural world. Now, let's shift gears a bit. Have you ever looked through a microscope to study cells? Well, the optical microscope you use in biology is based on some key principles of physics. The ability to magnify tiny objects relies on the way light bends, a process known as refraction. In fact, the electron microscope takes it a step further by using electrons instead of light, allowing us to see objects at a much smaller scale. Imagine studying a cell's nucleus or even a virus, something beyond the reach of regular light microscopes. That's where physics plays a major role. Example, the electron microscope uses the principles of electron diffraction to visualize structures at the molecular level. This helps us not only in biology but also in medical diagnostics, such as detecting diseases at an early stage. As you can see in the diagram, the relationship between physics and biology is fundamental in understanding living organisms and their structures. Ever gazed at the night sky and wondered what makes stars and planets move the way they do? Well, it's physics that explains the mysteries of the universe. From the motion of planets to the birth of stars, physics provides the framework for understanding all these phenomena. Take telescopes, for instance. These giant instruments use the physics of light to capture images from distant stars and galaxies. The Hubble Space Telescope, for example, collects visible and infrared light to study the universe beyond our reach. Example, when you look at a planet's orbit, you're seeing Kepler's laws of planetary motion in action. These laws describe how planets move in elliptical orbits around the Sun, and they were derived using the principles of physics. Formula: Kepler's third law states T superscriptura superscript 3, where T is the orbital period and r is the radius of the orbit. This relationship helps astronomers calculate the distance of distant planets based on their orbital periods. As shown in the diagram, physics is essential in the exploration of space and understanding celestial bodies. Let's now look at how physics and mathematics go hand in hand. Can you imagine trying to understand motion without equations? Physics relies on mathematics for almost everything, from calculating forces to predicting future movements. Take Newton's second law of motion, for example. The relationship between force, mass, and acceleration is a perfect example of how physics and math are linked. F is equal to m times a, where F is the force in newtons, m is the mass in kilograms, and a is the acceleration in meters per second squared. Mathematics doesn't just describe physical systems, it predicts them. The beauty of physics is that it's all based on mathematical relationships that govern how things move and interact. Example, electromagnetic theory, which describes how electric and magnetic fields interact, was formulated with complex mathematical equations that changed the way we understand energy and light. Physics doesn't just stop at chemistry, biology, and astronomy. It's the bedrock for many other sciences like biophysics, geology, and seismology. The fundamental laws of physics provide the principles that other sciences use to understand natural phenomena. For example, in seismology, the study of waves, which is deeply rooted in physics, helps us understand the movement of tectonic plates and predict earthquakes. Example, the study of waves and vibrations in physics explains the movement of seismic waves through the Earth, giving us insights into the planet's internal structure. Law, the law of conservation of energy, which states that energy cannot be created or destroyed, only transformed, applies across all sciences from the motion of planets to the vibrations in the Earth's crust. As you can see, the laws of physics aren't just abstract concepts. They play a role in understanding and shaping the world we live in, from medicine to earth science. Let's quickly recap what we've learned. We've seen how physics connects with chemistry, biology, astronomy, and mathematics, creating a web of interconnected knowledge. Whether it's studying atoms, exploring space, or predicting the motion of waves, physics provides the tools and equations to explain the world around us. Physics isn't just about what we see, it's the language of the universe, enabling us to understand everything from microscopic cells to the entire cosmos. I hope you now have a better sense of how physics influences everything from the structure of molecules to the motion of planets. See you in the next session with another fascinating concept of physics.